Okay, what's up? Today we're going to cover uh implications. Okay, and we're going to specifically cover the truth table, creating the truth table for an implication, and it's usually created using two statements. And then and we're gonna do that by providing some intuition with this real life analogy. Okay. And then we're gonna talk about some special cases, some truths, trivial and vacuous truths, and then yeah, some practice problems. And this is from I believe the geometry textbook that from that the website I provided in the last vid. Okay, so here's the backstory. Suppose that a teacher says that if you pass the final, then you can graduate. And consider the four scenarios below, and then answer the questions and briefly explain. Okay, so number one, you passed the final and graduated. Did the teacher lie? Okay, so you passing the final is like saying you met this condition, this hypothesis, right? So this is like saying the hypothesis, and uh, the hypothesis is the P here usually. It's the thing that comes right after the if, and then Q, and Q is the conclusion. So here, this is true, and you graduated. So that's true too. Okay. So this is like saying if true, then true. Did he lie? Did the teacher lie? No, right? Because you did it what he said and you graduated. Okay. So this is no, or this is basically he's telling the truth. Okay. Teacher told truth. You passed the final and didn't graduate. Okay, so you passed the final, so you did your part, T, but you didn't graduate. So he didn't do his part. The conclusion did not come true. So this is like saying T and F. Okay. And in this case, you did your part, but he didn't fulfill his. So here he lied. Okay. All right. Number three, you didn't pass the final, but graduated. Okay. So you didn't pass the final. That's like saying the P was false, right? And the conclusion, you graduated. So this was true. So did the teacher lie? Um, yeah, this is a misconception in real life to think that the teacher lied, but technically he didn't, because he didn't say anything about the case where you didn't pass. Okay. So similarly, number four, you didn't pass here too. Okay. So when you didn't pass, then it's like anything goes. Okay. So for number four, you didn't pass the final once again, that's F, and you didn't graduate. So that's like Q is also F. Okay. But since he didn't specify what would happen in the case you didn't pass the final, this the conclusion if P then Q would be true here in both. Okay, so now using these values, we can just fill in this table. Okay, so number one is like saying, okay, that was T, this was T, and the teacher told the truth. Okay, the second one was this is T, you did your part, he didn't, and this was false. And then here you didn't pass the final, so this was false, and then you didn't graduate. Oh, sorry, that's the fourth case. So this is T. FT, and then we said that sorry, what am I saying? So yeah, apologies. So we said in this case, right, that anything goes, so this is true. And then similarly in this case too. So you didn't pass and you didn't graduate. Okay. So this is true. And number four, this is kind of, convincing, and if you think about it intuitively, right? Because you didn't pass and you didn't graduate. So it's like, oh, it's like he did tell the truth. Okay. Um, okay, great. And then we said that these were the four cases. And if you notice very carefully, it looks like the truth value for this implication, it's true in almost every scenario except this one. Okay. The case where the hypothesis was true and the conclusion was false. Okay, and which is corresponding to two. Once again, I botched up here like a minute ago, right? But it doesn't matter so long as you cover all the cases. And like I mentioned before, in another video that this will probably be given to you. Okay, and this is pre-filled out in this particular order. So Yeah. Yeah, so number 5, this segues into number 5. What is the implication? When is the implication P implies Q false? We say when uh, the hypothesis. It's better to say the hypothesis because you could really mess with somebody and then use Q instead and P here, right? When the hypothesis is true and the conclusion is false. Okay, and when is it true? And you could say all other cases, or in these cases, these 3 cases. Okay, all right, great. So point 3, trivial and vacuous truths. Okay, so remember when I said that when the hypothesis isn't met, then anything goes. So when anything goes, you could say that, oh, you could just say that the implication is true. Sometimes they say that since the hypothesis wasn't met, this is the implication is true. The implication is true vacuously. Okay, and Google, that does not look right. Vacuous. Yeah, there you go. Okay. So yeah, this is true vacuously. And also specifically for number 3 and case 1, when you can show that the conclusion is always true, regardless of the p-value, so that would be in situation 1 and situation 3, right? Sometimes they say that the implication is trivially true. Okay, all right. And then yeah, so this is how you should remember or how to create the truth table. Okay. And then these exercises. Create a truth table for the logical statement below. So 39 to 41. It's using 2 statements, P and Q. So I know that this is going to be, it's going to have 4 rows. Okay, so you can fill this out. Now to get these other parts, well, you just need to know what this not means. This symbol means negation, and this means not. Okay, so I won't give the answers for this, but what you should do is you should create the table and create these intermediate columns, right? So if you know P, then you also know not P. Okay, how? Well, if you already filled this part out, TF, TF, and this is T, T, FF, right? If this is P, if P here is true, then not P here in this entry is going to be the opposite, which is false. And then here, T is going to, if this is T, then this is also false, and then this is T, and then this is T. Okay. And then you would do something similar if for Q and stuff. Okay. And to do 41, yeah, you're gonna have to create more of the other columns and then apply this, okay, to do these problems. Okay.